Thank you, Alison, and hello everybody. Good to see familiar faces as well here. So we wanted to check out what's going on with the LTE networks in the mass event, and we chose a hockey game in the local hockey arena to check out how the LTE networks are performing once we have a lot of people at one place. And here, this case is using our latest cloud-based monitoring and control system for the field units that are then measuring 3 different operators at the same time. So, the background for the study was to see how well the real-time monitoring works, but at the same time we wanted to see how well the LTE networks are bringing the service available for the paying customers. And you know, there's a lot of different types of the applications nowadays that the people are using, and the assumption is that there's a lot of traffic created with these 3 different types of apps that the smartphones are supporting. There's YouTube, social media, all kinds of news, and so on. One of the key things, of course, for the operators is to ensure that there's a service availability for the end customers, and the performance of the networks need to be there. Now, one of the challenges has been that how to follow these things in the real time. Typically, OSS systems are bringing you available the information a little bit afterwards, so you are getting then the information, let's say in 15-minute intervals from the network, and that comes a little bit later on. With this system, you can take the information from the venue at real time, and that is done with the latest smartphones, which will bring then the customer perspective to the measurements. So what we had unattended measurement units in the sports arena, and what it means, you don't need to have the technical stuff there. The units, the smartphones are measuring in an automated way, and how we control this, that goes from the cloud. The challenge for the operators typically is that if you want to have the service quality available from the end user customer in the real time, that has not been the case with the existing systems. So if you need to react to the errors that you might have in the network, hopefully not, there hasn't been that quick and cost-effective ways to do that. So if there are some errors with this system, you can react to the situation and then also fix the problems that you might see in the network. And of course, then one of the things is also to see what is the capacity of the LTE networks and how well the data is flying. Okay, oops, a little bit too quick. All right, this was the one. So this was our measurement setup. So we had autonomous probes or handies in the field. Then we were using then the cloud-based monitoring and controlling for the field units. Then for the post-processing and troubleshooting, we can use our analytics tools to dig into more details with the data. So how this cloud-based remote control works. So we have the web-based UI where we are first defining the project where we select the measurement units from the field which we wanted to have for the measurements. Then we define the measurement sessions that we want to have these units to do in the field. And then we define what are the reporting periods and how the results are sent back to the backbone. What we did here, we measured the data performance, and then we measured also the responsiveness of the network, as well as used some web-based services and applications to check out how the internet traffic or then the social media is doing with the LTE network. together with the performance data. So once all is set up and the units are starting to measure, what we had there was 3 different LTE networks with the latest smartphones, and the units were reporting then back the results to the cloud. And I will show you one example where you can see some of the statistics, some of the KPIs that you can see in the real time from the units, and that helps you to control and monitor the situation from the arena at real time. What else you can do with the system? You can then, of course, analyze the data later on if you need to dig in and get the statistics as well from the venue. This is most likely needed only for troubleshooting. So if something goes wrong, then you need to dig in deeper into the data that you're getting from the field units. So this is a view from our cloud-based monitoring system. Over there on the left, you can see the statistics of the data that you can monitor in the real time. So you will see if there's any access failures or transfer failures or things like that. And then at the same time, you can set up the thresholds for these kind of things. So of course you are not able to monitor everything at the real time from the one UI, so you need to set up the alerts which will help you to monitor the system. Then at the same time we are getting also the radio KPIs, for example, from the measurement units. So here on the right you are seeing then the parameters from the signal quality, and then the system information that which cell is serving, as well as the which channels are used in the measurements. All this happens in the real time, and if you want to see a demo, please visit our booth where in the demo area, and you will see then the measurements running in the real time, for example in Finland and in Australia. All right, and then to summary from the measurements. What we learned, well, we were able to monitor everything in the real time. We were lucky in a way that there wasn't that much problems with the accessing the data networks, or then having the problems with the transfers. Once we did then the post-processing of the data, we compared 3 different operators and then their data performance. And here on the up you can see the data performance averages during the period, so when the game was on. And the operator A had 2 carrier downlink in the use, and their peak throughput in the arena is around 270. So here we saw something like 200 megabits per second in the average during the period, which is really good because it means that there's a lot of capacity still need. We can see a little capacity effect also between the operators during the intermissions. So here in the red circles you can see that the capacity is dropped with the first operator something like 15% once the people start to use their smartphones. And here the worst example with the worst operator here in this case, the capacity was dropped something like 60%. But there's still capacity left. And that means that the LTE networks are powerful for carrying the data traffic. In the uplink path, we saw the similar trend, and the results were just about the same. Okay, what it means then for the web traffic, or then for the social media. For these kind of applications, still the amount of the data is quite small, and we didn't see big difference during the game or during the intervals between the periods in the social media or HTTP traffic. So here in this example we had a nice end result where the capacity of the networks was still there and the networks were performing as they should. But what we managed to do was to bring available the system that can monitor the sports arena in real time, and then bring available the data from the end user perspective in real time to the cloud-based systems. And if you want to see this in real time, please visit our booth and see the demo. Thank you.